welcome back to another video of H&H Express model and scale trains.
So this is part 4 of the series on how to use a remote control with an Arduino. And actually in this part I'm going to show you the functionality of using the remote control to have a train move on the track. So actually we're going to combine two sketches. A sketch which I built for the auto reversing unit with the Arduino, and the sketch for the LCD display and how I'm gonna use the remote control. But there is a little bit more into it, because as you see on the screen there is also an LED detected. So if I'm looking into our main loop here, I'm gonna explain that in a short. We have a built-in LED which is blinking. We have an infrared sensor detect, which are the both sensors on the right side and the left side of the track. And we have the remote control function. There is no delay function used in this script. We are using the millis script to keep that LED blinking. How that is done, I will show you that in a later section of this video, or part 2 of this video as well, because I'm gonna split it up, because otherwise it would be too lengthy. But first let me give a demonstration. So again, I use the same remote control. You need to press the on button to enable the plus and the minus and the off button. And as soon as you do that, if you hit the plus button, the train will speed up with a speed step 10, and then it will move to the right. If you press the minus button, then the speed will drop with minus 10, which means if you are at speed 100, if you press the minus button, it will go back to 90. And then you can go back in reverse. When it hits the 0, then it's minus 10, etc. So, but let me press the on button. So now you see on the screen, press the minus, plus or off button on the remote. I'm gonna press the plus, and it says plus key is pressed on the remote, speed step 10. Well, this train travels with a speed 100, 110, 120 before it moves. So let's press it multiple times to see when the movement of the train is happening. And it will move to the right. So 130, and we see that the train is crawling to the right. And when the sensor on the right detects the train, you will see what's happening on the screen, on the LCD. So it is detected, and it says right side track detected, the train has stopped. If I'm now going to press the plus button again, it detects that the plus button is pressed, but the train reached the end of the track. And that means that the train will stop. So now I'm going to press the minus. And you see it says minus 20, minus 40, minus 50, minus 60, minus 70. Let's bring the train in motion. So the train is moving. And when it hits the end of the track, it reports left side track detected, the train has stopped. If I'm now going to press the minus, again, the minus key has been pressed and it detected, and the train reached the end of the track. So I can now press the off button to power off. That means that the plus and the minus do not work anymore. But if you have looked closely, the blinking LED kept on blinking while the train was moving and while I was pressing. And it kept on doing that. So for that I'm using the millis function, which is within the Arduino, and then compare it with a start time and then with a stop time, and constantly update the millis, so the previous millis and the new millis with each other, and then calculate if a half a second has passed. So that is done in the built-in LED blink. The LED is connected to pin 13 of the Arduino, which is the same as on the Arduino Nano, Uno and Mega. So the IR sensor detect, that is used to control those sensors. So as soon as there is a detection made, then the train will do its thing. And then the remote control, it's just detecting that I pressed a key on the remote control. So we will dive into this and let's see how everything is connected. So here you see the schematic again for the connection of the sensors, the track, the motor driver and the Arduino. On top of that, we will connect the infrared sensor for the remote control. We're going to do that to pin 12, and we're going to connect the LCD display to the I2C bus, which are connected to pin 20 and 21 of the Arduino Mega. You need to look for the connection on a Uno and a Nano in your documentation. So first we're going to look at what happens when we use the delay function. So here I wrote a program. So I defined the built-in LED. In the Arduino it is called LED_built-in. I defined the off and on position of the LED. It all depends on how your Arduino is configured. Sometimes you need to flip it around, that when the LED is off, the output is low. When the LED is on, the output is high. In my situation, it is the other way around. I declared a counter, which is just an integer, and I'm gonna show that on the screen. So I wrote a function called built-in LED blink with the delay function, and I set the delay to 500 before I switch the LED to on, and then delay 500, and that's 500 milliseconds, then the LED is switched off. I'm gonna add up the counter, so counter equals plus plus counter, which means 1 is added to the counter each time, and I'm gonna print on the console the counter number, and then this message is displayed every second, because 500 plus 500 is 1000 milliseconds, and that means that this line comes after 1 second. In the setup, I initialize this serial port and I print the counter and then the information using the delay. I set the pin output of the built-in LED to output, and I do a built-in LED off, which means the initial is off. In the loop, I just call out the function built-in LED blink underscore delay. The reason why I created a function for this, because in the next step I'm gonna use millis, and I'm gonna show you what is happening when we add the millis to it. So let's upload this one, or let's compile it first. And actually on the Arduino, while it is compiling, you see that the power LED is on and the rest of the LEDs are off. And the top LED on the top LED on the left hand side is the built-in LED. So it finished compiling, so now let's upload it to the Arduino, and you will see that it is uploading by the transmit and receive LEDs. So it's now uploading, and you see that the top LED starts blinking, and the message on the console is this message is displayed every second. I put a timer in front, that's the time currently in the system, and you see that every second that message is displayed and the LED blinks off and on within that second. So if I'm gonna add in this loop another message. So let's say a serial.print ln test message, and I'm gonna compile that one. Then you will see that the test message is also displayed every second. So that loop takes 1 second to finish. You see the test message in between is shown every second as well. But I don't want that. I would like to have that test message, well actually the action after this, performed immediately. So the issue what we are having here is that the loop has a delay of 1 second before it continues with the next option. And when using the Arduino with the remote control function as I did, then I have an issue in handling that because it needs to be constantly monitoring, like sort of a multitasking task. And then the built-in LED needs to be blinking automatically as sort of a watchdog, but it also needs to be performing the other tasks in the program. So let's see how I did that. So in this program we're gonna use the millis function, and the millis function is updated every millisecond. That's where the name millis stands for. And to do that we're gonna first of all set some long integers, a current millis, because the number can be very large, and we set the current millis to 0 and the previous millis also to 0. To be able to monitor the LED and know the LED status of the built-in LED, I created a boolean which is set to false. Due to using many intervals, I defined an interval of 500 milliseconds over here. In the setup, I'm using the same pin mode as with the delay function, and the digital write up, I'm gonna turn the LED off first, and I'm gonna set the current millis and the previous millis the same with the millis function. So it will get at that time the output of the millis. Now in the delay function, what we saw, it was only 4 lines. So we set the delay to 500, but it waits. The program waits there for 500 milliseconds. Then it changes the status of the LED. It waits another 500 milliseconds, and then it changes the status of the LED again. That means that this function takes 1 second to complete. What we do with the built-in LED blink millis function, which I created, I'm comparing the current millis against the interval. So I do a current millis, subtract the previous millis, and check if it already passed 500 milliseconds. If not, I'm gonna update the current millis with millis, and then I'm out of that function. So it only takes a millisecond or less to run this. It depends on the clock speed of your Arduino. If it exceeds the 500 milliseconds, then I'm gonna set the previous millis the same as the current millis. I'm gonna look what the status is of the LED, and I'm gonna, so if the built-in LED status is false, then I'm gonna set it to true, and I'm gonna turn the LED on. If the built-in LED is true, then I'm gonna set the status to false, and I'm gonna turn the LED off. This will then be my function for the millis, and it will be called out here in the loop, built-in LED blink millis. So let me comment this one out so you see LED blink status in milliseconds. Let me compile this one and send it to the Arduino. So it's compiling the sketch, it's uploading to the Arduino, and here we see that on the console output the message is displayed every half a second. And you see that the millis number in front of blink of LED in approximately half a second or 500 milliseconds is changing. And you see that the number is growing and growing and growing. So if I now would enter, same what I did with the delay function, a serial.print test message. In the loop, and I would compile it and send it off, you will see the difference. So it's uploading the sketch, and this is what is happening. You see that the test message is coming in there multiple times, and in between you see that the LED message of the approximately 500 millisecond is coming in less. So that means that in the loop I can do more things than once. Now sending a message over the serial port always gets a sort of a delay, but at least you can see what is happening here. So that means that I can do a different task in between that the LED is still blinking. And the LED blinks and the message, the test message, is constantly showing. So let me comment out the millis here, so the serial print of the millis, because that takes up a little bit of time, and compile it, and we see what's happening. So it's uploading, and now it's flying by, and the LED on the Arduino is just blinking half a second off, half a second on. So that is what the millis function does, which means I can do multiple tasks at the same time if I'm doing it the right way within a Arduino. So next week we're gonna combine this watchdog LED together with the track and the remote control to operate a train, where we can see what was happening in the beginning of this video. So stay tuned till next week. So thank you for watching, and I will see you in a next video. Thank you and goodbye.